Alright guys, so we'll be trying to show you how to do binary search in this video. Since I know binary search and I don't know binary search at the same time, it would be harder than usual, I think, but I'll try my best to actually learn myself and show you guys how to do binary search too. So the first thing to do in binary search is, of course, write these two awesome legends. Once you did that, by the way, it is red because I think it cannot detect include the VS Code. I installed it new. I have to set up the whole thing, but it doesn't matter. What matters is writing binary code. All right, so just create a function main and do this. All right, but now we don't want to do this here. We want to do the binary search in a different function. We just want to like create a separate function and then do the binary search using that function. Where an array from C++, I think. Let's just do that. Let's create a new function called binary, and then let's give it 4 parameters. The first one will be an array from the main function. The second one will be left, a number that is to the left, a number that is to the right, and of course the number that we want. Let's just say want. Once we did that, so we will be doing this search using recursive functions. So because the recursive is kind of easier than iterative and it takes less coding, I think. I'm not sure. All right. So let's just say that if right is more or equal to the left, what this means is that we want to find the middle part. So let's just say middle would equal to the left plus right minus left divided by 2. This function right here, this will give us the middle number, like the middle of an array. Like an array, if it's like a zillion numbers, it'll give us 0.5 zillion, if you know what I mean. All right, once we did that, now the third thing is we want to do the, we want to do the if loop. If right, sorry, not right. If the array in this middle number that we just found, the middle element of an array, was more than the number that we want, then return binary. Since it's a binary, since it's a recursive function, we just do binary and then just give it array middle plus 1, because it's more than that, right? So do this binary function again on the other half, on the half that is more, like more than the middle number. Cut that in half and then do that. So it'll do that there, and then of course right, and then the number that we want. What this will do is, if this element that we want, the middle number, if this is more than the number that we want, which is maybe in our case is, what we have to do is return this whole function again, but do this, find a new middle number in the bigger half, and then do that. And then if it was again more, then again do that until you find the number. Or if the array of the middle, this middle element in the array was less than the number that we want, in that case what we have to do is return binary again, which is the function name, of course, and then array, and then what we want to do here is left, because it's less than that, right? But since it's less than that, what we have to do is cut the bigger half, not the bigger half. The right number should be middle minus 1, and then cut that in half, and then do again the whole process again. All right. So now the third case is if our middle is the number that we want. Okay, we cannot do that. We cannot cut the left half or the right half, of course. Then the third case, what we have to do is, let's just say if R, or the array in the middle number, is equal to the number that we want. What did you do in that case? What you have to do in that case is return what? It is hard, the middle number. Yeah, because that is the number you want, so just return that. All right, I think our function is done, or we have a fourth case too, okay? Let's just say, because the fourth case here would be if it was not there. what do you do now? If none of these cases like were satisfied, then return -1. -1, we'll just give it a case here. Like -1 is that it was not successful, and then we'll say here, right here, if let's just first create a new variable called, let's just say, result, and the results would be of course our binary, and then for this we'll have to create an array of integers. Let's just say n, and then we create an array called like, by the way, I'll do this array, I will make this array already sorted, but if you don't have a sorted array, then if in order for your binary search to work, you'd have to first sort your array and then do the binary search, because it'll not work if it's not sorted. Also, I can do sorted here too, but I don't want to make the video longer, so let's just say we already have a sorted array. Oh no, my bad. Sorry. 12, 45, 66, 78. Alright, let's just say this is our array. But now in array we have an n. And n would equal to, let's just say, 8. No, we cannot give it 8. Let's just say that our n is equal to how many? Oh my god, let's just give it a 8. Who cares? Let's just do it. Alright, now our result would be the binary search of this array, of course. And then what we have to do is start from the 0. From the left would be the 0, and then n would be n, of course, and then the number that we want. But as you can see here, we didn't specify what number we want here. We want the number that we want is 56. We want to know the index of 56. All right. So let's just say we did the function, we did the result. So now we would have to come to this part where if the result is -1 or the result does not exist. So let's just say if the result was equal to -1, then what we have to do is cout and say element not found 404. All right, so this would do is just cout it's not found if the result not found. Else if we found the result, of course, then we'd have to say element found at index, and then just do result here, because the result is the index number that we want to know. Right, time for running g++ binary.cpp. Oh god, result. Oh sheesh, let me just say result. Oh, what is happening? Oh, okay, what are you doing? Metal. Okay, where is metal? Here is metal. This is, oh shit. Okay, this is what I'm gonna do. I'm just gonna do this, and then we'll just keep it like that, because okay. All right, x. Where is x? Oh. Okay, this is the x thing. Please work, man. All right, n is initialized here. Int n. Okay, let's just say do this. And okay, let's just say that n is the size of the array. Size of the array, of course, and then this one, let's just divide it by the size of the 0. The 0th element, which will just give us the size, and then just leave it there. See what happens. What is wrong with you? Okay, clear. All right. Element not found? Element is found right there. Gosh. Okay, let's just do this. -1. What? Where did I make mistake? Okay. Middle would be the left minus that divided by that. Okay. Let's just do this. Okay. How about I do this? I bring all of them right here. And then since I already know what the third case would be, I would just do this. Because it's obvious it would be more than that. So no, my bad, I'm sorry. It cannot be. The third case should be this one. Okay, since the third one shouldn't, because if the first case doesn't match, the second case doesn't match, so the third one should match, which in our case would be what? What is going on? Okay, n minus 1, n plus 1. Okay, my bad. What we have to do here, if array is more than that, then just leave left on its own. Instead of writing right, what we just have to do is write the middle number -1 and then the number that we want. In here, we just leave left right on its own, but what we have to do is instead of writing left, we just do that right. Just clean this one. I think this is the error, but let's see. Ha! We did it, I think. 56. 1, 2, 3, 4, 5. Oh. 0, 1, 2, 3, 4, 5. Perfect. All right. Let's just say we want 560. Now, in this case, what happens now? Yee boy, since 560 is not here. All right, that was binary search.